Hello. Hi, everyone. This is the third part of the video text pre-training. So we will discuss the three more topics on the right side of the tree, so including application to video understanding, unified modeling, and more languages. So we will start with the unified modeling, then we will discuss the application to video understanding. Then we will briefly talk about the work that uses the language other than English. Then for the unified modeling, we will discuss two different types of the work. One is modality-agnostic model design. Another one is task-agnostic model design. Then for the video understanding, we will talk about some extending work using contrastive training for model designing. And then there we will discuss some works that try to leverage the pre-trained model on the text model, and also some prompt tuning technique for the work. So we will start with the unification. So for modality unification, usually the work is try to develop a network that can handle the different modality at the same time. And for the task unification, we will try the work or try to usually the work when you train a model for downstream, you have to have a fine-tune with the different head for different tasks. So this one is focused on to unify the visual language task by as a text generation. So for invocation on modality this one usually close. Oh,
microphone, are you? Yeah, get closer.
Gotcha. Okay.
Okay. So the common model designing usually use the separate model-specific encoder to get a better feature than using a multi-modal fusion to try to fuse the features. Here, for modality, we try to develop a model that can take directly to the text and video input, or more modality like the audio or text. So this is one work is in this year's CVPR called Uniperceiver. So the goal is try to develop a modality-agnostic transformer encoder with a lightweight modality-specific tokenizer, then to unify handling the different modalities. So on the right-hand side, it shows that the previous task-specific perception model usually need a different model to handle different type of the modality. For example, the video and video for video classification and text image for VQA and image retrieval. They need different type of model. And text will need a different model. here they try to develop a unified model, and they can take different type of arbitrary, taking different type of the model and fit into either the input part or the target part. Then you can project the goal. The training goal will be to encode the different tasks of input and target on arbitrary modality and into a unified representation. So let's look at the more detail of this model. So we can see that there's a transformer encoder that can share with the input and target modality. So the target and input modality, they can take different type of input or modality, then you can try to project to a unified representation. On the right hand side, it shows that the different part for handling different modality is the tokenizer, the text tokenizer and image tokenizer. The differences in the position embedding. For the video part, they will add an extra temporal embedding. So with this type of the model design, they are able to pre-training on a variety of different type of data set. For example, the image net and kinetic addressing pure image or video data set, and also can handle PAQ, this type of pure text data set, and also the multi-dataset. And on the right hand side shows that how they handle those different combination of the data set and try to project them to the unified representation. So the goal. So after pre-training, it shows that the performance they only need 1% of the target data and do the prompt tuning to get a very good performance, like as good as the state of art, but with fully fine tuning, they can achieve much better or as good as the state of art. This is one type of the unified modeling. Another type of thing. So this work is another work we will discuss is called all-in-one. This one is specifically developed for video language training. So also try to handle the different modality in one model. As we can see that the result shows that the model can achieve very high accuracy with a very low flux. So in this model, in this paper, the author argued that the important temporal information is the key hurdle to hinder the pre-training performance, especially for video language pre-training model. So they design a special operation called token rolling operation to encode the temporal representation from the video clip to a non-parametric manner. So we can see that on the right hand side, there's 3 different frames, 1, 2, 3. Each frame has a text token M and region token N. So if they want to have a fully attention to all these 3 frames, they will require M plus 3 N's square complexity. So they develop a rolling operation that will shift the tokens between frames. Then the attention only happens in a local rolled tokens, and they show that it's very effective way to reduce the computational complexity and also be able to learn the important information from temporal relationships. So on the bottom part, it shows that with the fully attention, the density is shown on the green part. The pink part shows the attention distribution on the row token. So it shows that the attention will focus on the row token to learn the temporal relationship. So this one, the pre-training is using the web BID 2.5 million and also the hot 100 million. And the experiment result shows that you could get like previous one, you can get a very high accuracy and also low flux computational complexity. So another one in this unified modeling category is the work of SkillNet. The SkillNet is trying to develop a sparse multimodal MOE model. So then the bottom part try to show that the MOE model can be effectively using a sparse activating module to get a very good result. And the right-hand side shows that how they decide to activate which part of the model. This depends on what it depends on what kind of modality is. So this type of model, the different part of the parameter can specialize for processing different modality. So this is the more detailed example that they handle the text information and the visual information. They activate some different part of the expert and also and share some part of the network. So this is the four network looks like. It can handle different type of the modality, not just only text and image or video. It could include sound and code. And the experiment result shows that without the pre-training, the downstream task result can achieve the almost like state of art other method, and with the pre-training, the performance can be improved significantly, and also using very few active parameters. So yeah, previous three network is talking about the modality, unifying the modalities. And now we will talk about how the work related to task unifications. So this part, usually we can see that in the green part, the common work will, when they apply after the pre-training, when they apply the downstream tasks, then require different type of the head to fine-tune and tailor for each specific tasks. But no, we are not focused on the backbone here. So, but the goal is try to handle different tasks with the same set of the network. So there's a latest work called Lavender, and quadratic model will be introduced later. And this type of model is including GIT and Flamingo. They also use the text generation to handle different type of downstream tasks. So here is the Lavender concept. So how do we do the unified pre-training and also downstream fine-tuning in the same way. So Lavender proposed using a masked language modeling. So in the pre-training, we can use modeling, masked language modeling, and also convert other tasks as a masked language modeling. For example, you can see that the video text matching and the text to video retrieval, it can be framed as a text input, then we will put the answer at the end to mask it, then ask the network to answer it's true or false. Or even for multiple choices for video QA, we can give the network the video input and also the question, and with the options of the answers, then the network will train to answer which answer is the accurate one. So naturally, this work is also perfect for video captioning. So because it's trained on the masked language modeling. So this is the main concept of this work. So compared to this slide shows the comparison to existing method and the Lavender on the pre-training part. So the pre-training part on the left-hand side, it shows the common video language method that using extra head, multi-language head, and also VTM head to perform different type of the pre-training. And for in the middle part, it's the existing image text modeling with with the unification is done by the prefix to decide which kind of task the pre-training is currently trained on, and also this type of the model require a large decoder, and for Lavender they only need a simple MLM head, and then can do both type of the MLM and also VTM pre-training. And also for the downstream one, we don't, this is the comparison of the existing method on the downstream image and also video question answering task. So for the existing video language method, they need a QA head and extra QA to fine-tune on like extra QA head, and in order to perform these tasks. And for Lavender, we don't need to use any extra head. Just keep the same set of the parameters. We can do the same approach. So how effective this method is? The experiment shows that Lavender can surpass the previous method with a task-specific design. So this type of the unification of task-agnostic unification design can achieve the state of 12 different type of the video language tasks. So it shows that this type of the design can be very effective and also open the opportunity that can include more different type of tasks in a unified way. So another one is another work is try to leverage a different type of the pre-trained model. The work called Socratic model. So we have a lot of different pre-trained model trained on very large data set. They all have a different form of the common sense knowledge in a different domain. For example, the large language model, they are learning a lot of different knowledge from different like spreadsheet, SAT or question or call, and the large visual language model are trained on a large scale image captioning. They have a different type of knowledge and also some audio model as well. So the paper is arguing that this type of the model, the first state is symbiotic. That means that those different type of the knowledge from the different type of model are beneficial to each other. So they design the model to leverage those different type of the knowledge from different type of model and try to create a Socratic model that is mainly using the prompting and engineering to design a prompting that can gather the information from different type of the model and then do the downstream task. On the right hand side is an example. They get the information from the predefined prompting, then they can get the reasonable captioning results. And this is another figure to illustrate the concept of this paper is try to gather the information from language model, the visual language model, and also audio language model to come up with a guided multi-modal discussion. Then it can perform different type of the tasks like video search, image captioning, and freeform QA, etc. So this is another type of the unified model. And later we will talk about a different topic is about the application to video understanding. Here we will talk about 3 different topics. We'll quickly go through those topics. One is the extension of the contrastive model on the video, and also the how to transfer one work about transferring an image text model to action clip, and another one is by leveraging the trained model and with the prompt tuning to transfer those models to video understanding. So that coming from the original paper from MIRNC, the How to 100 Million paper, that they still have several work try to based on those contrastive learning to improve the representation learning. So we can see on the left-hand side is try to leverage the audio, video, and text, and use because the audio and video they have this aligned feature they use in NC, and left-hand side the text and use is from Azure, and they have a less alignment with the audio and the video, so they use the MIRNC. And the innovative part is try to leverage the temporal information to get the positive pair and also negative pair, and also using the ranking to leverage hard negative mining. On the right hand side, they went further to design 3 different types of the contrastive learning, contrastive laws. One is the sentence level contrastive laws, and also the token level contrastive laws, like for example the noun, verb, and adjective, and also a third laws is for hard negative mining. The experience shows that you could effectively train a better representation and achieve the starter part. The second one is this one is try to based on the clip text, they will try to reframe the video classification framework as previously they have to the classification is to generate a number that's mapping to the predefined the task label, and then they want to achieve the similar architecture like FLIP. They try to extract to attach the importance of the semantic information to the label text rather than the simply mapping them into a number. So they, based on the FLIP text model and also visual model, they put the extra frame in there and further design the post-network rounding, and they investigate different type of the design and to see which one is more effective for video action classification. This type of understanding work. So another work is another direction is trying to do prompting. Is given the trained model like click the text part and the text model and the visual model, they fix it, and by the only designing some type of the continuous prompting to or human readable prompting to improve the video understanding tasks. So first one is the continuous prompting vector. Is try to design the red part here is the prompting vector, which is random and learnable. Other part of the model is fixed, like a clip image model and a clip text model. The transformer is learnable as well. So they will be able to learn the prompting vector and to achieve for different type of the downstream tasks like action recognition, text video retrieval, and action organizations. And the third one is it's another work called Bridgepoint. They try to simultaneously explore the both out of context and the contextual information from a series of ordinal action, like an instructional video, like cooking or making salad. So this one is trying to develop different type of the prompting, including the sequence, like the first day the person is making a head, then using this type of the prompting and with the statistic prompting, like for example, there are 4 actions in this table, and the network will based on this prompting and the fuse with the image features and do the contrastive learning and to achieve the better understanding on those instructional video and get a better result. The data set on something like salad 50, this type of data set. And final, we will talk about briefly talk about more language. So there are 3 works related to this language. So one is the multimodal multilingual multimodal pre-training. So this work we found that if we want to do the zero-shot cross-lingual transfer, the traditional model will the performance will drop sharply. So they try to they create a data set from the how to 100 million and with the different type of language, and then when they do the training, they do the contrastive learning between the text and also the video features, and the result shows that they can dramatically improve the post-model zero-shot transfer. And also, this one is for specifically designed for Chinese video, since they also create a data set with a different type of label with the title and also detail type abstract and also the category, and you can let the developer model to handle this type of data set. And this year CVPR also have released a large scale benchmark for multi-modal similarity evaluation. This is the, yep. So this is the summary of the talk that we talk about the different type of application to the video understanding, and also different type of the unified modeling, and also some work related to more languages. Here, for going forward, I think this type of the work are pretty new, and also still have a lot of room to explore. Like for example, the one challenging part for video language pre-training is the data quality is not that good. So for further development of the pre-training method is also important. And also there are some work trying to leverage the video language part for the temporal understanding, like 10 and flat. So this is also a possible direction to have a better understanding of the video training, and also unified modeling. There are some initial try of this type of the modeling, but still there are a lot more type of the future work can be explored. Yep. So, yep, this is my talk. Okay.